Medieval alchemy holds secrets that shaped our modern world. For centuries, we have dismissed these early experimenters as superstitious fools chasing gold, but their forgotten science laid the very foundations of chemistry and medicine. By the end of our journey, you will understand how their relentless quest for transformation directly led to the scientific breakthroughs we rely on today. What was the true purpose behind their mysterious symbols and volatile experiments? How did their failed attempts to create gold accidentally forge the tools of modern science? What does our own drive for discovery share with the ambition of an alchemist hunched over a flickering flame? A solitary scholar works through the night, his shadow dancing in the flicker of a single flame. He is surrounded by a labyrinth of glass vessels and leather-bound manuscripts, but his eyes are fixed on the slow transformation unfolding before him. For centuries, we have caricatured this figure as a greedy fool obsessed with gold, yet that image shatters against the truth. The ultimate prize, the object of this profound and perilous quest, was something far more elusive: the legendary Philosopher's Stone. This was not merely a substance to create wealth, but a key to unlock the deepest secrets of existence. It was believed to hold the dual power of transmuting base metals into gold and, more importantly, conferring eternal life. The great alchemist Paracelsus captured the essence of this pursuit when he declared that the art of alchemy was to make the invisible visible. This was a search for the fundamental principles governing all of nature, a grand attempt to read the hidden language of the universe itself. Their work was a complete fusion of the material and the spiritual. Alchemists saw a direct parallel between the purification of a lump of lead and the refinement of the human soul. Each experiment in their smoky laboratories was a microcosm, a small-scale model of cosmic processes. The fire that heated their flasks represented divine fire. The alembics and retorts were symbolic wombs for new creation, and the quest for the stone was a metaphor for humanity's own journey toward perfection. This was not superstition divorced from science, it was science infused with meaning. Their laboratories, for all their strange symbols and secretive recipes, were the birthplaces of systematic research. Here, they developed meticulous procedures for distillation, sublimation, and fermentation, laying down the practical groundwork for all of chemistry to come. They were not just mixing potions, they were pioneering the very concept of experimental method, blending hands-on chemistry with a profound philosophical framework. Can you feel the echo of their ambition in our own time? The modern scientist in a lab coat, searching for a cure for a devastating disease, is driven by the same transformative impulse as the alchemist seeking the elixir of life. The engineer developing a new material to reshape our world is pursuing a kind of modern transmutation. Our relentless drive for innovation, for breakthroughs that push the boundaries of the possible, is a direct descendant of the alchemist's quest. They set the stage for all that was to follow, and their greatest experiments were only possible because of the ingenious and often dangerous tools they invented. Within this chaotic workshop, every tool had a purpose as profound as the quest itself. The centerpiece was often the athana, a towering furnace of brick and clay. Its name comes from an old Arabic word for furnace, and its genius lay in its slow, steady burn. Unlike a common fire that flares and fades, the athana was designed to maintain a constant temperature for weeks or even months. This was not a tool for haste, it was an instrument of patience, mirroring the alchemist's belief that true transformation could not be rushed. It provided the gentle, continuous heat needed for the long, mysterious processes of digestion and coction, where materials were believed to mature and perfect themselves. Alongside it sat the elegant glassware of the alembic, a device for distillation. Its name comes from the Greek word for beaker, and its design was remarkably sophisticated. An alchemist would place a mixture in a rounded vessel called a cucurbit, heat it, and watch as vapors rose into the cap, or alembic proper, only to cool and trickle down a spout into a waiting receiver. This process of separating a liquid's pure essence from its grosser components was a physical enactment of a spiritual ideal, purifying the impure. One of their most fundamental techniques was calcination. This involved roasting a solid substance, often a metal or mineral, in a shallow dish over an open fire until it was reduced to a dry, powdery ash. Think of what happens to a log in a fireplace, leaving behind only white, brittle charcoal. For the alchemist, this was not destruction but liberation. They believed calcination broke down a material's stubborn outer form, releasing its trapped spirit and making it ready for rebirth into a new, more perfect substance. Every procedure, from sublimation to fermentation, was carried out with meticulous care. Failures were not discarded, they were studied. Each unexpected color change, each strange residue, each explosive miscalculation was a new sentence in the hidden language of matter they were desperately trying to decipher. This relentless, hands-on engagement with the physical world, this culture of careful observation and recorded experiment, created a foundation of practical knowledge that would prove indispensable. And the materials they subjected to this rigorous testing were as strange and varied as their apparatus, beginning with the most infamous of all, Mercury. The philosopher's stone was never meant to be a simple lump of rock you could hold in your palm. It was a symbol, a key intended to unlock the universe's deepest operating principles. Alchemical texts, often attributed to the mythical sage Hermes Trismegistus, described it with cryptic names like the red tincture or simply the great work. These terms pointed toward something far greater than mere wealth. The stone was believed to be a physical catalyst capable of perfecting matter, turning lead into gold, and also a spiritual elixir that could perfect the human body, granting health and even longevity. This was the ultimate goal, a substance that bridged the gap between the material and the metaphysical. The search for it was not a single experiment but a lifelong journey of transformation. Procedures with names like fermentation and multiplication were not just chemical steps, they were allegorical representations of nature's own cycles of decay, rebirth, and growth. Some practitioners firmly believed that creating the stone was impossible without a parallel process happening within the alchemists themselves. Your own moral and intellectual refinement, your personal enlightenment, was the true crucible. An impure soul could never hope to perfect base matter. This is the core of the mystery, the beautiful, frustrating duality of alchemy. It demanded rigorous, hands-on experimentation with real, often dangerous, materials while simultaneously requiring a profound internal, philosophical journey. The laboratory work and the spiritual work were two sides of the same coin. This holistic view of the universe, where every chemical reaction echoed a change in the human spirit, is what made alchemy so powerful and so enduring. Its allure challenges us to ask a profound question about our own time. Can a symbolic, almost mythical goal, like the quest for eternal life or perfect knowledge, actually drive tangible, practical scientific progress? The answer lies in the very experiments born from this pursuit, where symbolic ideals were tested in the unforgiving reality of fire and glass. That careful sequence of heating and mixing was far from random ritual. It was a direct application of the era's most advanced scientific theory, the Aristotelian model of matter. alchemists believed everything in the physical world was a blend of four fundamental elements: earth, air, fire, and water. A piece of lead was not seen as an element in itself, but as a specific, imperfect mixture of these four. Gold was simply the perfect, balanced mixture. The entire goal of transmutation, therefore, was to rebalance the elements within a base metal, stripping away its perceived impurities and guiding it toward metallic perfection. This was not magic, it was early material science. They developed specific processes to achieve this theoretical rebalancing. Ceration was one such technique, where a solid was slowly heated with liquids until it softened into a waxy, malleable paste. This was thought to make the material more receptive to change, ready to absorb new properties. Another crucial method was sublimation, the dramatic process of turning a solid directly into a vapor and then condensing it back into a purified solid, leaving impurities behind. Think of the frost that forms on a cold window pane from the invisible moisture in the air, a physical transformation that would have seemed miraculous. The alchemist was trying to do the same with metals, to purify and elevate them through these physical trials, and sometimes their experiments yielded stunning, if misleading, results. When they worked with antimony, for example, they could create a stunning, silvery white alloy that, under the flickering light of their lamps, could easily be mistaken for a step toward gold. These accidental discoveries were not failures in their eyes, but confirmations that they were on the right path. Each shimmering surface, each unexpected color change, was a clue in the grand puzzle of matter. Their quest was built on a logical, testable framework, and their relentless attempts to prove it, even in failure, forged the tools of modern chemistry. This same drive to manipulate nature's fundamental building blocks for human benefit finds a direct parallel in their other great, and equally elusive, ambition, the pursuit of eternal youth. While their furnaces glowed with the promise of gold, another quest burned just as brightly in the alchemical mind: the search for the elixir of life. This was not merely about extending years, but about conquering sickness itself. Alchemists believed that just as a base metal could be perfected into gold, the human body, riddled with disease and decay, could be restored to a state of perfect health and balance. They operated on a powerful idea, the concept of a panacea, a universal remedy that could cure all ailments. This belief was deeply intertwined with the dominant medical theory of the era, Galenic medicine, which held that illness was caused by an imbalance of the body's four humors: blood, phlegm, black bile, and yellow bile. The alchemist's goal was to create a chemical key to reset that balance. This fusion of chemistry and healing gave birth to an entirely new field, iatrochemistry, or chemical medicine. Its most famous champion was the brilliant and abrasive Paracelsus, who openly challenged the medical establishment of his day. He famously burned traditional medical texts in a public bonfire, declaring that the true purpose of alchemy was not to make gold but to prepare medicines. He and his followers began systematically experimenting with plants and minerals, creating potent tinctures and extracts. They developed a specific alchemical technique for this purpose called spagyrics. This complex process involved carefully separating a plant into its three essential principles, using fermentation to access its spirit, distillation to capture its volatile soul or mercury, and incineration to extract its fixed body or salt. These purified components were then meticulously recombined, creating a finished remedy believed to be far more powerful than the original herb. The aim was a medicine that could treat a vast spectrum of illnesses, from fevers to wounds. Paracelsus put these radical ideas into terrifying practice. He began treating syphilis, a devastating and widespread disease, with compounds of mercury. While we now know mercury is a dangerous neurotoxin, his treatments did seem to produce results, likely because the mercury killed the bacteria causing the infection, even as it slowly poisoned the patient. This controversial approach highlighted a critical and often tragic duality. The same substance could be both a potent cure and a deadly poison, with the difference lying only in the dose and the preparation. Despite the risks, these endeavors were not blind guesswork. Alchemists became meticulous documentarians of cause and effect. They recorded recipes, purification methods, and most importantly, patient reactions, establishing foundational principles for the entire field of pharmacology. Their search for longevity through chemical means forced them to ask the same questions modern drug developers grapple with today: how to purify an active ingredient, how to standardize its strength, and how to understand its effect on the human body. This perilous dance with toxic substances, however, was just one part of a much larger and more volatile story, one that unfolded in the heart of the alchemical workshop itself. A shimmering droplet of liquid metal rolls across a stone table, refusing to settle into any solid shape. This was Mercury, the alchemist's most enigmatic and dangerous partner. They called it quicksilver for its fluid, living motion, and they believed it was the primordial essence of all metals, the very soul of metallic matter. Its unique ability to dissolve gold and silver, to form silvery amalgams with other metals, was seen as a form of digestion, a key step in the process of transmutation. If you could first break a metal down into its mercurial soul, the theory went, you could then rebuild it into something perfect. This made mercury a cornerstone of their greatest work, a supposed primary ingredient in the legendary philosopher's stone itself. They employed it in a process called amalgamation, carefully mixing the liquid metal with powdered gold or silver. The resulting putty-like substance was thought to be a material on the cusp of transformation, a metallic embryo awaiting the final push to become the stone. In more volatile experiments, they used mercury in sublimation, heating it to produce thick, dense vapors. These fumes were believed to carry the metal's transformative spirit, a volatile power that could infect and alter other substances placed within the apparatus. The risks were catastrophic and largely ignored. Prolonged exposure to mercury vapors attacks the central nervous system, leading to tremors, mood swings, hallucinations, and a slow, creeping madness. We recognize this now as the same erethism that plagued felt makers, the so-called Mad Hatters, who used mercury nitrate in their trade. Alchemists working in poorly ventilated labs would have suffered the exact same fate, their dedication to the quest literally poisoning their minds. Yet, in their perilous obsession, they were unknowingly cataloging the fundamental behaviors of matter. They were documenting phase changes, watching a metal become a vapor and then a solid again. They were studying volatility and the powerful reactions that occur when substances change their state. Their dangerous dance with quicksilver provided foundational insights into metallic behavior that would later become cornerstones of metallurgy and materials science. This willingness to confront such a beautiful, deadly substance highlights a stark truth about the path of discovery, that the road to a breakthrough is often paved with profound personal risk. And just as mercury represented the soul of metals, another element was needed to provide the spark of transformation, the fiery spirit of sulfur. That bright yellow crystal, burning with its strange blue flame, embodied the very spirit of transformation. This was sulfur, the second great principle in the alchemist's cosmic recipe. If mercury represented the fluid, metallic soul, then sulfur was the fiery essence of combustibility and change. It was the active, masculine principle that gave matter its properties of color, smell, and volatility. Alchemists saw its pungent fumes as the very breath of a substance, the proof that something dynamic and powerful was being released. They believed that all materials were composed of a marriage between Mercury and Sulfur, and that the perfection of gold was simply the most stable and harmonious union of these two principles. To manipulate matter, you had to understand this fiery partner. They used sulfur in countless experiments, often observing its dramatic interactions with metals. When they heated sulfur with iron or copper, for instance, they watched as the shiny, familiar metal transformed into a dull, brittle, and often brightly colored substance, a metal sulfide. This was not just a simple change, it was a revelation. It demonstrated that a metal could lose its defining luster and malleability by combining with another element, a fundamental insight into chemical reactivity. One of their most significant discoveries came from the distillation of vitriol, a term for various metallic sulfates. By carefully heating green vitriol or iron sulfate, they could produce a dense, oily liquid sulfuric acid. This was a monumental achievement, the creation of one of the most powerful and versatile acids known to chemistry. Its corrosive power was terrifying, yet it also became an indispensable tool for dissolving ores and purifying other substances. In these smoky, acrid procedures, alchemists were unknowingly documenting the core concepts of oxidation and reduction. They were watching metals be oxidized by sulfur, and they were developing methods to reduce ores back into pure metals. Their meticulous records of these color changes, weight gains, and gas emissions would later provide the raw data for entire chemical theories, including the famous phlogiston theory that attempted to explain combustion itself. Sulfur taught them that the universe was not static, but a seething arena of constant change and reaction. Yet, for all this fiery volatility, a third principle was needed to provide solidity and form: the enduring structural element of salt. A heap of pure white salt crystals represented the final anchor in the alchemical universe. While Mercury was the elusive soul and sulfur the volatile spirit, salt was the enduring body, the principle of stability and corporeality. It gave matter its solid form, its tangibility, and its resistance to fire. This was the third member of the Tria Prima, the three primal principles that alchemists believed composed all things. Salt was the earthly element that provided structure, the necessary foundation upon which the dance of transformation could occur. Without this stable base, they reasoned, the fiery spirit of sulfur would simply burn away, and the fluid soul of Mercury would evaporate into nothing. Their experiments with salt were just as hands-on and revealing as their work with more dramatic elements. They practiced a technique called salification, carefully combining acids and bases to witness the formation of new salts. In one common process, they would react common salt with sulfuric acid, producing hydrogen chloride gas. When this gas met the ammonia fumes from decomposing organic matter like dung or hair, it created a white, crystalline smoke that settled as sal ammoniac or ammonium chloride. This was a triumph of purification through sublimation, and this salt became a vital reagent. Metalworkers used it as a flux to clean surfaces of molten metals, allowing for better soldering, while physicians incorporated it into medicines, believing it could help dissolve tough phlegms in the body. By observing the precise geometric patterns of salt crystals forming in a solution, alchemists were documenting fundamental principles of purity and composition. They saw how a pure substance would consistently form the same beautiful shapes as it crystallized, while impurities would disrupt the pattern. This was a powerful, visual lesson in chemical identity. They were exploring solubility, watching some salts dissolve in water only to be forced back out or precipitated by adding another substance. These careful observations of how salts interact in solution laid the groundwork for the entire modern understanding of ionic compounds, even if they had no words for ions or electrolytes. The symbolic weight of salt was equally profound. It represented wisdom, preservation, and the enduring essence of a thing. Just as salt preserves meat from decay, the alchemist sought to preserve the true, perfected essence of a metal or a medicine. This physical work in the laboratory was a mirror for their own spiritual goal, to cultivate a stable, incorruptible character, a soul with the enduring purity of a perfect salt. In every experiment, they were not just manipulating matter, they were reading a hidden language, one where every reaction, every color change, and every crystalline form was a word in nature's secret text. A dragon coils endlessly around a glass vessel, its tail disappearing into its own mouth. This was the Ouroboros, a symbol of nature's endless cycles of death and rebirth, mirroring the alchemical process of distillation where a liquid is boiled, vaporized, and then condensed back into a purer form. This was not mere decoration, it was the very language of alchemy, a complex code designed to conceal and reveal in equal measure. Alchemists developed this rich symbolic system for two vital reasons: to protect their volatile knowledge from those who might misuse it for greed or power, and to express abstract philosophical concepts that plain language struggled to contain. How else could one describe the dissolution of gold, the king of metals, except through the vivid image of a green lion devouring the sun? This dramatic symbol often represented the moment gold was dissolved in a powerful mixture of acids called aqua regia, a process that felt like a mythical beast consuming the celestial body itself. Authors like Michael Mayer composed entire books of intricate emblems, where every animal, every celestial sign, and every human figure was a precise allegory for a laboratory procedure or a stage of inner spiritual development. A recipe for a potent tincture might be described as the sacred marriage of the king and queen, a symbolic union representing the combination of sulfur and mercury, the fiery and fluid principles of matter. This encoded communication demanded deep study and initiation. It forced the reader to think in multiple dimensions, blending art, mythology, and hands-on science into a single, integrated pursuit of knowledge. The goal was not just to follow a set of instructions, but to understand the underlying principles of the universe. This tradition reveals the alchemist's profound belief that knowledge was a unified whole, where a chemical reaction and a spiritual truth were simply different expressions of the same cosmic law. Their cryptic manuscripts were not just hiding secrets, they were teaching a way of seeing the world, a method of thinking that connected the smallest experiment to the grandest philosophical idea. These beautifully illustrated pages, filled with dragons and lions, became the vessels that carried this fragile, integrated wisdom through the centuries, preserving it for a future that would eventually learn to read its hidden truths. These handwritten manuscripts were not just books, they were living laboratories captured on parchment. Picture a page from the Rosarium Philosophorum, its margins crowded with frantic notes beside elegant illustrations of the king and queen. Here, an alchemist recorded a failed experiment, noting the exact shade of orange the mixture turned before it violently boiled over. There, he sketched a modified alembic that finally yielded a clear distillate. Every smudge, every correction was a data point in a grand, lifelong experiment. This meticulous record-keeping was the alchemist's version of a modern lab notebook. They documented everything: the weight of ingredients, the duration of heating, the subtle shifts in color and odor. A recipe might call for the fire to be maintained until the matter passes from the black of the crow's head to the peacock's tail, a vivid description of the iridescent colors seen during certain chemical reactions. This was more than poetry, it was precise observational science, using the best descriptive language available to them. While symbolic codes protected their work from the uninitiated, the core of these texts was a rigorous attempt to understand cause and effect. The survival of these volumes, copied and recopied by hand across centuries, created a fragile but continuous chain of knowledge. It allowed a practitioner in Prague to build upon an observation first made in Cairo 200 years prior. This tradition established the very idea that experimental data, even from failed attempts, had lasting value and must be preserved for future generations. It was a quiet revolution in how humanity collects and transmits practical knowledge. These precious manuscripts did not gather dust in isolation. They were the currency of a hidden intellectual network, exchanged and debated in the vibrant cultural hubs of the medieval world. Behind those cryptic European manuscripts lay a world of brilliant light and meticulous scholarship, while monasteries in the north carefully preserved fragments of ancient knowledge. The great Islamic caliphates were actively building upon it. In the bustling libraries of Baghdad and Cordoba, under the patronage of enlightened rulers, a grand project of intellectual synthesis was underway. Scholars fluent in Arabic, Greek, and Persian were not merely translating the works of ancient masters, they were scrutinizing, correcting, and vastly expanding them. This created a rich, systematic foundation of chemical knowledge that simply did not exist anywhere else in the world. It was through these vibrant centers of learning that the forgotten science of Alexandria was reborn and systematically prepared for its journey into Europe. The most influential figure in this tradition was the 8th century scholar Jabir ibn Hayyan, known in the West as Geber. His contributions were so profound they reshaped the very structure of alchemical thought. Jabir championed the idea of rigorous, repeatable experimentation, insisting that all theories must be tested in the laboratory. He developed and perfected essential techniques that are still fundamental to chemistry today, including crystallization, where pure solids are formed from a solution, and filtration, the process of separating solids from liquids using a porous barrier. He systematically classified substances, distinguishing between volatile spirits, metallic bodies, and soft stones, creating an organized framework for understanding matter. Perhaps his most lasting theoretical innovation was his theory of balances. Jabir proposed that the properties of every metal were determined by a precise balance of its fundamental qualities, like heat, cold, dryness, and moisture. To transform one metal into another, you did not need magic, you needed to meticulously recalibrate this internal balance. This powerful, logical idea that transformation was a matter of correcting elemental proportions would become a cornerstone of European alchemy for centuries. When his works, along with those of other Islamic scholars like Al-Razi, were translated into Latin in the 12th century, it was nothing short of a revolution for the European mind. These texts introduced Europe to the very concepts of the elixir and the philosopher's stone, not as vague myths, but as tangible goals achievable through systematic laboratory work. The Islamic emphasis on quantitative methods, on careful measurement and observation, began the crucial shift of alchemy away from pure mysticism and toward a more disciplined scientific approach. This was not a simple transfer of information. It was a cross-pollination of intellect that demonstrates how knowledge, like a river, flows across borders, enriching every discipline it touches. The integration of these Islamic innovations provided European alchemists with a new toolkit, both practical and philosophical, setting the stage for the unique figures who would later walk their own path of discovery. A Franciscan friar's cell in 13th century Oxford was far more than a place of prayer. Within its quiet confines, Roger Bacon conducted experiments that defied the intellectual conventions of his age. While his contemporaries debated ancient authorities, Bacon insisted that true knowledge came from direct interrogation of nature itself. He championed the radical concept of experimental science, arguing that claims about the natural world must be tested and verified through meticulous observation and mathematics. His own alchemical research was breathtakingly broad, delving into the properties of light and vision, the explosive potential of gunpowder, and the creation of medicinal compounds. He saw no conflict between his faith and his science, believing that studying nature was a way to understand the divine handiwork, yet his relentless curiosity inevitably drew suspicion from religious authorities who viewed his methods as dangerously unorthodox. Across the continent, another churchman walked a similar tightrope. Albertus Magnus, a Dominican bishop and teacher of Thomas Aquinas, was a giant of medieval thought who combined profound theological scholarship with hands-on alchemical investigation. He did not just read about minerals and metals, he collected them, tested them, and recorded their behaviors with painstaking detail. His writings on alchemy and mineralogy are filled with practical observations on how to distinguish one metal from another, or how different compounds react when heated or mixed. He served as a vital bridge, connecting the theoretical knowledge preserved from antiquity with the emerging culture of direct, empirical inquiry. Both Bacon and Magnus faced a fundamental tension. Their positions within the church granted them access to knowledge and the freedom to study, yet their pursuit of that knowledge through experiment often challenged the very institutions that supported them. Bacon's bold calls for experimental verification and his critiques of blind acceptance of authority were, in many ways, a preview of the scientific method still centuries away from formal recognition. Magnus provided a powerful template for systematic inquiry, demonstrating that the natural world could be understood through careful, repeated testing. Their legacies force us to see these figures not as reclusive mystics, but as courageous investigators operating at the very frontiers of knowledge. They willingly embraced the personal and professional risks of asking questions that had no sanctioned answers. Every measurement they took, every reaction they observed, was a small act of defiance that helped pave the road to modern chemistry. Their progress, however, was only made possible by the precise tools they wielded, instruments designed to quantify a world that had previously been described only in qualitative terms. That careful calibration of a balanced scale was more than mere preparation. It was a quiet revolution in thought. Alchemists were coming to understand that the secrets of matter could not be unlocked by guesswork alone. Precision in weighing reagents, even if their units of measurement varied from one workshop to another, was the key to repeating a successful experiment and, more importantly, to truly understanding why it had succeeded. This growing demand for accuracy drove the evolution of their entire toolkit. Furnaces were redesigned with better insulation and more sophisticated air vents, allowing an alchemist to maintain a specific temperature for days, not just hours. This was not just an improvement, it was a transformation in their ability to control the very environment of their experiments. Retorts and beakers made from stronger, more heat-resistant glass could withstand greater internal pressures, enabling them to explore more volatile reactions without the constant risk of shattering. With these sturdier vessels, they could perform complex procedures like fractional distillation, a method of carefully separating a mixture into its component parts based on their different boiling points. Think of it as slowly unraveling a tangled thread by gently pulling on each individual strand. The classic alembic and its cucurbit vessel were endlessly refined, the angles of their spouts and the thickness of their glass optimized to capture every precious drop of a distilled essence. This was not just about building better gadgets, it was about building a more reliable window into the hidden workings of nature. In the realm of medicine, this focus on precision became a matter of life and death. The introduction of graduated measures like marked flasks and standard-sized spoons allowed iatrochemists to move beyond vague potions and begin standardizing dosages. They could now record that a specific volume of a distilled tincture produced a predictable effect, creating the first primitive formulas for reproducible remedies. We see this meticulous approach clearly in their experiments with gold and mercury. An alchemist would carefully note the exact weight of gold dissolved into a specific amount of quicksilver, observing the resulting amalgam with a quantitative eye. They were documenting proportional relationships, the fundamental basis of all chemical analysis, even if they lacked the formal language of atomic theory. Every improvement in their equipment, every scratch mark on a measuring flask, represented a step away from mystical speculation and toward a world of verifiable, repeatable results. This tangible progress in the workshop, this marriage of clever hands and precise tools, could not have happened without an equally sophisticated map of the universe to guide them, a theoretical framework built on the ancient concept of the four elements. A universe of swirling change could be anchored by just four simple principles. Earth, water, air, and fire were not merely substances but the fundamental qualities of existence itself, each defined by a pair of opposing states. Earth was cold and dry, water was cold and wet, air was hot and wet, and fire was hot and dry. Every material object, from a lump of lead to a human body, was believed to be a unique mixture of these four elemental qualities. This elegant Aristotelian system gave alchemists their first comprehensive map of reality, a logical framework that explained why and how matter could change. A piece of wood burning in a fire was not being destroyed. It was undergoing an elemental rebalancing as the wet and cold qualities of the wood were driven off, leaving behind the dry, earthy essence of ash. This was a powerful, predictive model. If you wanted to transform a substance, you simply needed to adjust its elemental makeup. To purify a metal, you might heat it repeatedly, driving off its watery and airy impurities with fire to isolate its perfect, earthy metallic body. Dissolving a salt in water was not just mixing, it was liberating the salt's watery essence, allowing it to recombine with the universal water element. Even the seemingly magical process of distillation made perfect sense within this model. When a liquid was heated in an alembic, the alchemist watched as it seemingly transformed from a watery state into an airy vapor, which then traveled through the apparatus only to condense back into a purified watery essence in the receiver. Each stage of the process was a visible demonstration of elemental transmutation, a small-scale model of the cosmos's endless cycles. This theoretical backbone transformed random mixing into systematic inquiry. It encouraged alchemists to ask structured questions. If I add more of the fire element through prolonged heating, how will the balance of qualities in this mineral shift? If I separate the watery component of this plant through distillation, will its medicinal power become more concentrated? The theory provided the why behind their meticulous how. While we now understand matter through the lens of atoms and molecules, the four elements offered something equally vital for its time, a coherent, testable system that made the chaotic world of chemical reactions feel intelligible and open to human manipulation. It was this very drive to manipulate elemental balance that led them to master one of chemistry's most vital techniques, a process that would become their greatest practical legacy. A shimmering drop of pure alcohol forms at the end of the alembic spout, a liquid fire captured in glass. Distillation was the alchemist's most elegant dance with the elements, a physical poetry of transformation. They watched as a murky, complex liquid was heated, its spirit rising as an invisible vapor only to be tamed by the cool coils above, condensing back into a purified and potent essence. This was not just a technique, it was a philosophical demonstration, a miniature model of the cosmic cycle of death and rebirth. The gross, earthly body was left behind in the boiling flask, while the purified soul was captured in the receiver. This process became the very heart of their practical work, allowing them to isolate the active principles from plants for medicine and to create the powerful reagents needed to attack metals. Figures like Mary the Jewess were not just practitioners, they were brilliant engineers of their age. Her invention of the tribicos, a three-armed distillation head, was a leap forward in efficiency. Instead of a single stream of distillate, this device collected the precious liquid through three separate spouts, allowing for a greater yield and a more controlled process. Such innovations enabled the creation of aqua vitae, the water of life, which was essentially pure ethanol. This concentrated alcohol became a vital solvent for extracting medicinal compounds from herbs, far more effective than water or wine. More dramatically, by distilling mixtures of saltpeter and vitriol, alchemists produced fuming, corrosive nitric acid. This was a game-changer, a liquid powerful enough to dissolve silver and even to attack gold when mixed into aqua regia. In their bubbling glassware, they were unknowingly documenting the fundamental concept of volatility, observing that different substances turn to vapor at different temperatures. When they repeatedly distilled wine, each cycle produced a more concentrated, more flammable spirit, demonstrating an intuitive grasp of fractional separation centuries before it was formally defined. Their drive to purify, to separate the essential from the mundane, provided chemistry with one of its most vital tools. Yet this mastery over liquids demanded a parallel expertise with solids, a process of purification by fire rather than by vapor. A crucible glows with fierce heat, holding a substance until it cracks, blackens, and finally crumbles into a fine, pale ash. This was calcination, the alchemical art of destruction as a prelude to creation. Alchemists would place metals, minerals, or even plants in shallow dishes and subject them to relentless heat in the open air, watching as the materials lost their familiar forms. They saw this not as annihilation, but as a necessary liberation. By burning away the volatile, corruptible parts of a substance, they believed they were stripping it down to its essential, pure body, a primitive matter ready for rebirth into something new and perfect. When they roasted lead ore in this way, they witnessed its transformation into a yellow or red powder called litharge. This was not just a different substance, it was lead in its most fundamental state, a base material now prepared for the alchemist's transformative art. This meticulous process forced them to become keen observers of physical change. They noted how the weight of a metal often increased after calcination, as it combined with something from the air. They could not name this process oxidation, but they documented its effects with painstaking care, gathering early, crucial data on how matter interacts and changes under the influence of fire. Symbolically, calcination was a powerful metaphor for the death of the old self. Just as a metal had to be reduced to its core essence, the alchemist's own ego, with all its impurities and attachments, had to be burned away in the furnace of introspection and discipline. This parallel between the material and the spiritual was the heartbeat of their work. A soul cluttered with vice was like an impure ore, unable to achieve the golden state of enlightenment. Every time an alchemist watched a substance calcine, it was a physical reminder of their own necessary internal purification. The empirical value of this violent breakdown was immense. By systematically reducing countless substances to their ashes, alchemists compiled a vast, if unsystematic, catalogue of how materials behave under extreme heat. They learned which minerals released specific gases, which metals formed colorful calxes, and how these purified powders could then recombine in new and surprising ways. This foundational knowledge of thermal decomposition became indispensable for later metallurgists extracting metals from their ores and for chemists understanding the fundamental composition of compounds. But to create something new, destruction alone was not enough. The pure, barren ash left by the fire now awaited its opposite, a process of combination and synthesis that would give it new life. A fine red powder emerges from the swirling union of mercury and sulfur, a vibrant testament to the alchemist's power to create. This was the process of coagulation, the final, patient act of bringing purified substances together into a new, unified whole. After the destructive fire of calcination and the purifying ascent of distillation, coagulation represented the crowning achievement of integration. It was the moment scattered elements were guided into a stable, cooperative form, a new substance with properties entirely distinct from its parents. In one celebrated procedure, alchemists would carefully combine liquid mercury with powdered sulfur, heating the mixture until it solidified into a brilliant red compound we know as vermilion. This was more than just making a paint. It was a symbolic marriage of the metallic soul and the fiery spirit, resulting in a stable, beautiful product that became one of the most prized pigments of the medieval world, used to illuminate sacred manuscripts and create vivid works of art. The principle extended far beyond pigments. When an alchemist dissolved a metal in acid and then added another substance to force a solid to fall out of the solution, they were performing precipitation, another form of coagulation. They watched as a new salt, with its own unique crystalline structure, would slowly form and settle, a tangible creation born from a liquid union. Or consider the making of an alloy, where different metals were melted together in a crucible, their individual identities surrendering to form a single, stronger material like brass or bronze. In every case, the alchemist was demonstrating a profound insight that the combination of ingredients could yield something greater than the sum of its parts. They saw this as a mirror of nature's own creative processes, where simple elements coalesce to form complex organisms. This holistic view forced them to consider relationships, not just ingredients. How did one substance affect the behavior of another? What conditions were necessary for a stable union to occur? Their skill in guiding these reactions, in knowing just when to add a reagent or adjust the heat to achieve a perfect coagulation, marks an early, practical grasp of the principles of chemical bonding. It was this hard-won, hands-on knowledge of how to build new materials from the ground up that would provide an indispensable foundation for the vast, industrialized world of metallurgy yet to come. That same red powder, vermilion, was more than a pigment. It was a testament to the tangible power of alchemical principles, a power that echoed far beyond the laboratory and into the very forges that built the medieval world. Within bustling foundries, the line between mystical pursuit and industrial craft blurred into a single, practical reality. The alchemist's relentless drive to understand and perfect metals directly translated into stronger alloys and more efficient methods of extraction, fueling economies and technological advancement. Their systematic work in assaying, the process of determining the precious metal content in an ore or coin, provided the financial bedrock for trade, ensuring trust in currency and the value of mined materials. This was not abstract theory, it was applied science. They developed sophisticated techniques for smelting, using carefully designed furnaces and controlled airflow to separate pure metal from rocky ore with unprecedented efficiency. One of their most significant contributions was the innovative use of fluxes, substances like limestone that were added to the molten metal. These fluxes acted like a chemical sponge, bonding with rocky impurities to form a separate layer of slag that could be easily skimmed off, leaving behind a much purer, more workable metal. This simple yet brilliant application of chemical principles revolutionized metal quality. The quest for transmutation itself yielded profound industrial rewards. The process of cementation, for instance, was a direct offspring of this pursuit. Alchemists would pack bars of iron into a sealed clay chest along with charcoal or other carbon-rich materials, then heated for days. They hoped this prolonged, intimate contact would somehow transmute the iron, and in a way it did. The iron did not become gold, but it absorbed carbon, transforming into a much harder and more durable material, steel. This was a kind of practical transmutation that shaped weapons, tools, and armor. Through such systematic testing of ores and furnace conditions, alchemists also played a role in identifying and characterizing new metallic elements, expanding the very catalogue of materials available to human industry. This collaboration between the alchemist with his theoretical frameworks and meticulous records, and the craftsman with his hands-on skill and understanding of real-world constraints, created a powerful synergy. It was in these smoky, collaborative workshops that abstract ideas met the test of fire and hammer, proving their worth not in philosophical treatises, but in the strength of a sword blade or the reliability of a coin. This seamless transfer of knowledge from the philosophical to the practical forces a compelling reflection. Can the relentless, often spiritual drive to perfect matter be the very engine that produces our most vital, worldly advancements? The true alchemist's greatest transformation occurred not in the crucible, but within the soul. Envision the practitioner in deep meditation, the slow, rhythmic processes of the laboratory serving as a perfect mirror for their own inner journey. Purifying a base metal of its impurities was a direct parallel to the grueling work of overcoming one's own base desires and ego. This was the heart of spiritual alchemy, a discipline where every external experiment reflected an internal, psychological struggle. The stages of the great work were not just chemical, they were maps of the human spirit. The initial stage of nigredo, the blackening, represented a descent into despair and confusion, the necessary death of the old self. This was followed by albedo, the whitening, a phase of purification and washing away of inner corruption, leading toward clarity and hope. An influential text like the Chemical Wedding of Christian Rosenkreutz was not a literal recipe, but a profound allegory for this initiatory path. It used the rich imagery of alchemical marriage and transformation to describe the soul's arduous journey toward wisdom and self-realization. This perspective demanded that the alchemist cultivate specific virtues, seeing them as essential for success in both realms. The immense patience required to tend the Athana's fire for months was the same patience needed to endure spiritual dry spells. Humility in the face of constant experimental failure taught humility before the mysteries of the divine. Personal integrity was paramount, for a deceitful heart could never hope to produce a pure substance. Even the balancing of sulfur and mercury in an experiment had its inner counterpart, the delicate art of harmonizing one's fiery passions with the fluid coolness of reason. This integration of spiritual aspiration with hands-on scientific practice created a comprehensive worldview that is almost foreign to us today. Knowledge of the material world was not an end in itself, but a means to a higher, more profound understanding of existence. The laboratory was a chapel, and every procedure was a form of active prayer. This beautiful, dual focus on perfecting both matter and spirit reveals the immense depth of alchemical thought, a system that refused to separate the seeker from the search. Yet such a powerful, secretive, and ambitious pursuit could not exist without attracting suspicion, controversy, and the ever-watchful eyes of authority. A king's court could be a perilous stage for an alchemist's craft, where a failed demonstration meant more than a ruined experiment. It could mean a charge of fraud or even heresy, with the stakes being one's reputation, freedom, or life. This constant tension between genuine inquiry and outright deception plagued the field for centuries. On one side stood serious practitioners like Thomas Norton, who argued passionately that their work was a pious investigation of God's creation, a legitimate science seeking to unlock nature's lawful secrets. On the other side, a flood of clever frauds exploited the allure of gold, using sleight of hand with hidden gold dust or double-bottomed crucibles to produce a shimmering result for a wealthy patron before disappearing with the funding. The prevalence of these charlatans was so damaging that even Pope John the 22nd felt compelled to issue a papal decree, not against alchemy itself, but specifically against those fraudulent alchemists who falsely claimed they could transmute metals, condemning their deceptions as a moral crime. Religious authorities frequently viewed the alchemist's power to manipulate nature as a challenge to divine prerogative, a trespass into realms reserved for God alone. Could a mere human presume to perfect what nature had left imperfect? This fear often painted their laboratories as dens of diabolical activity. Simultaneously, a new breed of emerging scientific thinker began to demand verifiable, repeatable results over mystical claims and secretive symbolism. The alchemists' refusal to speak plainly, to abandon their coded language for clear public demonstration, increasingly opened them to accusations of obscurantism. This legacy of ambiguity, where profound chemical discovery was interwoven with spiritual aspiration and outright fraud, has made it incredibly difficult for history to separate the pioneering scientist from the misguided mystic or the cunning con artist. Their struggle for credibility in the face of institutional skepticism and internal corruption mirrors a recurring theme in the history of knowledge. Every revolutionary idea must first fight for the right to be taken seriously, battling the ghosts of its own worst practitioners. This very battle, fought in smoky laboratories and grand courts, would ultimately force a necessary evolution, pushing the quest for transformation toward a new, more rigorous language of proof. A modern laboratory, with its precise glassware and controlled reactions, is a direct descendant of the alchemist's workshop. The very techniques a chemist uses today, from distillation to the careful titration of one solution into another, were forged in those smoky, secretive rooms. This is the unbroken lineage of experimental practice, a bridge built not of stone but of methodical curiosity. When Robert Boyle began his own investigations into the nature of gases, he was building upon the alchemical insistence that theories must be tested against physical reality. His famous work, The Skeptical Chymist, was a direct challenge to the old Aristotelian elements, yet it was born from the very empirical tradition that alchemy had kept alive for centuries. The concept that matter was composed of tiny, particulate bodies was not a new idea from the 17th century. It was a central, if poorly defined, principle in alchemical thought, one that would eventually crystallize into our modern atomic theory. Even the idea of chemical affinity, the mysterious attraction that draws certain substances together, was first explored by alchemists watching Sulfur marry with Mercury. They documented these preferences of matter, creating a primitive map of reactivity that later chemists would formalize into the periodic table. Isaac Newton himself spent decades transcribing alchemical manuscripts and conducting his own private experiments with metals and reactions. His profound understanding of light and gravity did not emerge from a vacuum. They were shaped by a mind deeply engaged with the transformative processes of matter, seeing the same universal laws at work in a falling apple and a bubbling crucible. The shift from alchemy to chemistry was not a sudden revolution where one discipline died and another was born. It was a slow, deliberate refinement. The mystical framework of spiritual transformation was gradually peeled away, while the invaluable core of systematic experimentation, meticulous record-keeping, and hands-on manipulation of materials was retained and strengthened. In the realm of medicine, this legacy is even more tangible. The alchemical preparation of minerals like mercury and antimony, for all their danger, established the radical idea that specific chemicals could target specific diseases. Their spagyric methods for extracting the essence of plants created the first standardized tinctures, establishing foundational principles for drug purity and dosage that every pharmacist still relies upon. So why was such a foundational field relegated to the footnotes of history, remembered more for its mythical quest for gold than for its profound contributions to science? Perhaps its integrated vision, which wove together the material and the spiritual, became incompatible with a new scientific age that demanded a strict separation of objective fact from subjective experience. The very wholeness of the alchemical world was the reason it had to be left behind, even as its practical tools became the bedrock of our modern world. A quiet revolution was brewing not in secret laboratories, but in the public halls of new scientific societies. The founding of institutions like London's Royal Society in the 1660s marked a profound shift in how knowledge was made and validated. Their motto, nullius in verba, meant take nobody's word for it. This was a direct repudiation of the alchemist's secretive tradition. Knowledge was no longer to be guarded in coded manuscripts, but tested openly, reproduced by peers, and debated in plain language. The new mechanical philosophy viewed the universe as a great clockwork, understandable through mathematics and measurement, not through symbolic correspondences between the soul and sulfur. This emerging culture of transparency and quantification left little room for the alchemist's holistic, secretive world. A pivotal figure in this transition was the humble schoolteacher John Dalton. By meticulously weighing gases and observing how they combined, he developed his atomic theory, proposing that all matter was composed of tiny, indivisible particles of specific weights. This was a death knell for the ancient four elements. Water was not a fundamental substance, but a compound of hydrogen and oxygen atoms. Fire was not an element, but a process of rapid combination with oxygen. Dalton provided a precise, quantitative framework that could predict chemical behavior in a way the qualitative language of earth, air, fire, and water never could. The final, decisive blow came from the brilliant Frenchman Antoine Lavoisier. With his supremely accurate balances, he demonstrated the law of conservation of mass, proving that matter is neither created nor destroyed in a chemical reaction. There was no mystical loss of essence during transmutation, just a rearrangement of atoms. His oxygen theory of combustion completely overturned the phlogiston theory, which was itself a direct descendant of the alchemical concept of sulfur as a principle of fire. Lavoisier's work systematically dismantled the theoretical pillars of alchemy, cementing chemistry's identity as a modern, rigorous science. In this new, rational atmosphere of the Enlightenment, alchemy's association with the occult and its long history of fraudulent gold makers made it a subject of ridicule in academic circles. It was cast as the superstitious past, an embarrassing relic to be discarded on the path to progress. And so the great forgetting began. The baby was thrown out with the bathwater. The invaluable practical techniques of distillation, calcination, and fermentation were absorbed into the new science of chemistry, but the spiritual and philosophical context that gave them meaning was stripped away. The laboratory remained, but the chapel was closed. This pattern of preserving useful tools while discarding their original world-view is a recurring theme in the history of knowledge. We inherit the methods but lose the meaning. Yet, what if some of that discarded wisdom held insights we are only now, centuries later, beginning to rediscover? A 21st century laboratory uses a beam of light to read the secrets of a 500-year-old flask. Advanced spectroscopy, a technique that analyzes how matter interacts with light, has detected microscopic residues of highly purified antimony and mercury sulfide inside vessels once dismissed as mere props for superstition. These are not the traces of haphazard mixing, but the chemical fingerprints of intentional, sophisticated processes. This is the new frontier of alchemical research, where historians, chemists, and archaeologists are collaborating to reread the past with tools the original practitioners could never have dreamed of. They are discovering that many so-called mystical recipes were, in fact, meticulously detailed instructions for creating substances of remarkable purity. When these ancient formulas for acids like aquafortis are replicated in modern labs, they yield results that match the descriptions in the manuscripts, proving a level of reproducible technical skill we had entirely underestimated. Historians of science now openly speak of alchemy not as a failed magic, but as the direct and valid precursor to chemistry. It was in these workshops that the very concept of an experimental protocol was born, along with early, hard-won lessons in laboratory safety, like using protective glass and proper ventilation to handle toxic fumes. This reappraisal reveals a discipline that seamlessly wove together hands-on empirical testing with a deep, philosophical inquiry into the nature of reality. Their quest was not just to make a substance, but to understand the principles behind its creation. In our own era of hyper-specialization, this integrated model of knowledge, where the practical and the philosophical inform one another, offers a powerful lesson. The past is not a static record to be memorized, but a living conversation to be rejoined. Every time we re-examine an alchemical text with fresh eyes and new technology, we are participating in that same great work of interpretation and discovery. And this renewed respect for their intellectual journey forces us to confront the profound ethical questions they themselves wrestled with in the shadows of their furnaces. A profound moral weight settled on the alchemist's shoulders with every discovery. The power to heal or to harm, to purify or to poison, resided in the very same flask, and this duality was a central, sobering part of their tradition. The true adept was not measured by the gold they could make, but by the wisdom with which they wielded their knowledge. Greed and pride were not just personal failings, they were seen as active corruptions of the work itself, ensuring any transmutation would fail. A soul clouded by selfish ambition could never hope to produce a pure substance, for the inner state of the alchemist was believed to directly influence the outcome of the experiment. This ethical framework was crystallized in texts like the Emerald Tablet, with its famous axiom, "as above, so below." This was not merely a statement about cosmic correspondence, it was a moral command. It demanded that the alchemist's actions in the laboratory reflect the same harmony and balance they perceived in the heavens. To create a healing elixir with a malevolent heart was a fundamental contradiction, a violation of the natural order. The ultimate goal of creating the elixir of life, for example, was rarely framed as a quest for personal immortality. It was a mission to alleviate human suffering, to heal the sick and contribute to the common good. This sense of responsibility forced them to confront the same questions we grapple with today. When a powerful new technology emerges, who gets to control it? What prevents it from being used for exploitation rather than enlightenment? The alchemist's careful, secretive transmission of knowledge was in part an attempt to answer this, a gatekeeping mechanism to ensure that dangerous power did not fall into unprepared or malevolent hands. Their entire practice was a prolonged meditation on the dual-use potential of discovery, a recognition that the same fire that purifies gold can also burn down a city. This ancient awareness of the bond between innovation and ethics feels startlingly relevant now, as we stand at our own crossroads of scientific power. Their forgotten science offers more than just the roots of chemistry. It offers a timeless mirror for our own ambitions, reminding us that the most profound transformation is not of lead into gold, but of knowledge into wisdom. Their quest for gold forged the tools of modern chemistry, a legacy not of magic but of method. We have walked through the smoky laboratories where the dream of the philosopher's stone drove centuries of relentless experimentation, from the patient heat of the Athana to the elegant dance of distillation. These were not fools but pioneers who mapped the hidden language of matter, developing the very processes of purification, combination, and analysis that define our scientific world today. Their greatest insight was a holistic one, a refusal to separate the transformation of matter from the refinement of the human spirit. This integrated pursuit, where empirical testing walked hand in hand with philosophical inquiry, offers a powerful model for understanding. It reminds us that our deepest quests for knowledge often bridge the tangible and the intangible, the laboratory data, and the human wonder that gives it meaning. The legacy of these forgotten scientists is a testament to curiosity, perseverance, and a truly interdisciplinary spirit, one that continues to inspire researchers who now blend fields like biology, physics, and material science to solve complex problems. The Alchemist's workshop, a place of both profound mystery and rigorous method, echoes in every modern lab where we still seek to transform the base into the brilliant. Their story urges us to look beyond simple caricatures and to uncover the deeper truths hidden within history's most misunderstood chapters. Let this journey be a starting point, a spark for your own curiosity about the hidden roots of our world. What other ancient wisdom, once dismissed, might hold the key to our future? Share your thoughts on how these forgotten paths continue to inform our modern discoveries in the comments below.